Okay, it sounds like you're starting to learn to solve quadratic equations. Quadratic equation is something that looks like this. In standard form, ax squared plus bx plus c equals 0. A cannot equal 0, otherwise you have a linear equation. But b could equal 0 or c could equal 0. And there's four primary ways to solve a quadratic equation. The square root property, factoring, complete the square, quadratic formula. The quadratic formula actually comes from the operation of completing the square, and this is what this problem focuses on. How do you solve a quadratic equation by completing the square? Now here in this black print, we're reviewing squaring a binomial. If you have x plus 3, the quantity squared, that means x plus 3 is used as a factor twice. If you use FOIL, you get x squared plus 3x plus 3x plus 9. And if you combine those similar terms, this is what we call a perfect square trinomial. You can write it as a binomial squared. And there's actually a shortcut for squaring a binomial. If you use the technique on that first row several times, you'll start to realize there's a pattern. Square the first term, x squared, double the product of the two terms. So negative 5x doubled means multiplied by 2 is negative 10x plus 25. If you square a binomial like 2x plus 7, you get 4x squared. The product of the two terms is 14x doubled is 28x plus 49. Okay. Here's the formula for squaring a binomial to get what's called a perfect square trinomial right here. Those are your two quote formulas. So I'm going to solve this equation by completing the square. You could also solve your original problem by factoring, but you're asked to do it by completing the square. So here's the idea. Completing the square is pretty easy to do when the leading coefficient is a 1, when a is 1. But you also learn to do it when it's not a 1, I'm sure. And especially when b is an even number, it's easy to complete the square. Here's the technique. Take the constant term to the other side by subtracting 12 in this case. How do you turn the left side into a perfect square trinomial? We're going to leave a space right here for completing the square. Take half of b, which is negative 5, and square it. That's just like this guy right here. Half of b squared is 25. But if you add 25 to the left side of the equal sign, you have to add 25 to the right side. That step is called completing the square. I just turned this into a perfect square trinomial. But this trinomial can be written as x minus 5, the quantity squared, which I showed over here. Basically, if this leading coefficient is a 1 and you complete the square, x minus half of that number is what the binomial will be. Over here, we've got negative 12 plus 25 is 13. Take the square root of both sides. That's actually the square root property. When you take the square root of a positive number, there's two square roots. This doesn't come out even. So it's not a perfect square, so we just write it as plus or minus the square root of 13. Add 5 to both sides, and we've got what x is. Those are your two solutions for that quadratic equation that I showed up here. Now, if we go to board 2 and do the same thing that we just did on the previous board, we already have the constant term on the right side. Let's leave a space for completing the square. What goes here? Since the leading coefficient is a 1, take half of b, which is 6, and square it. 36 is what completes the square. This perfect square trinomial can be written as x plus 6, the quantity squared, equals 49. Take the square root of both sides. Well, the square root of 49, there's two square roots, plus or minus 7. Subtract 6 from both sides. Negative 6 plus or minus 7. We can say the roots are negative 6 plus 7 is a 1, or the second root is negative 6 minus 7, which is negative 13. And we could have done that, so reached these results by factoring the original equation, x squared plus 12x minus 13 equals 0, factors into x minus 1 times x plus 13, set each factor equal to 0, solve each equation, you get these two results. Okay, now remember, what I just showed you only works if this leading coefficient is a 1. And it's a little more difficult if this number is not even. Also, you'll probably learn how to solve a quadratic equation by completing the square, like if you have a 3 here. But it's quite a bit more involved. So focus on these easy kind first. There you go. Hope that helped. If you have any questions, post a comment.